Hi everyone, this video is an exercise 11D question 2, and in this video I'm going to do parts I and j. So in part I, we want to integrate sine x times cos x over square root of cos 2x plus 3. Okay, so this very complicated looking fraction can be simply integrated by the reverse chain rule. So first of all, it's better to rewrite this in the form sine x times cos x. And now the denominator can be written as cos 2x plus 3 to the power of a half. But if you want to have that in the numerator, then the power changes to negative. So we get cos 2x plus 3 to the power of minus a half dx. Now, the whole point of doing this was to realize that this is of the form that is reverse chain rule basically, because first of all, if you look at here, it's sine x times cos x. So you can use the double angle formula to rewrite this. That's the first thing that we may need to do at this point. So here we have sine x times cos x, and essentially by using the double angle formula, this is basically the same as having 1 over 2 sine 2a. So if you rewrite this as 1 over 2 sine 2 x basically, not a. So now here the interesting thing is that this actually looks like the not exactly, but it's very similar to the derivative of cos 2x. So that's basically the main trigger here that allows us to use the reverse chain rule to integrate this. So the first educated guess here is cos 2x plus 3 to the power of a half. So when we differentiate this, we'll have a half times, now cos 2x differentiates to minus 2 sine 2x, and then we have the bracket, but with the half minus 1, which becomes minus half. Now, when we simplify this, so a half times minus 2 is just basically minus 1, and we have minus sine 2x. So we get minus sine 2x, and remember that sine 2x can be rewritten as, so I'm writing that out of a space. So for minus sine 2x, we can rewrite this as minus 2 sine x cos x, and then cos 2x plus 3 to the power minus a half. Now, when we compare this to the actual fraction, in the fraction we have this term, that's just in the denominator. And also, this part is on the numerator, but this minus 2 is extra. So we must have another constant of minus 1 over 2 outside. So therefore, the answer is minus a half cos 2x plus 3 to the power of a half plus c. So this is the answer here. So now in part J, this is very similar to what we had in part I, but in the denominator, we don't have a square root anymore. And that's very important because the approach now is about, still it's reverse chain rule because the numerator looks like the derivative of the denominator. But this time, this is the type that we should use the len. So the len of the denominator is basically the educated guess here. So len of cos 2x plus 3. And so one question is that how can we understand that when is the time to use other forms of a trigonometric function? So for example here, how should we know that we should use the form half sine 2x rather than sine x times cos x? So the answer is very simple. You just need to look for the consistency. So in this case, the denominator is 2x, but the numerator, you have sine x and cos x. So it's x, but denominator is 2x. So you always like to, want to keep all of them the same so that the calculations become much easier. Now, in this case, so the guess is len cos 2x plus 3. Now, let's differentiate this. So when we differentiate, the denominator is cos 2x plus 3. Numerator is simply the derivative is minus 2 sine 2x. Now, when we compare this to this expression here, this expression, the denominators are the same, and then the difference is that on the numerator, we have basically here is a half, but here is minus 2. So that means if we multiply this by minus 1 over 4, then therefore we'll have a half here. So that's basically the adjustment here, that it must be minus 1 over 4, then cos 2x plus 3, and also plus c as the final answer.